Okay, last question, question 17. The lithium button cell used to power watches and calculators is a primary cell containing lithium metal. The lithium ion cell is a secondary cell that is used to power laptop computers. Excuse me. What is the difference between a primary and secondary cell? Okay, nice and straightforward. Primary cell cannot be recharged. Secondary cell can be recharged. And then also, in a primary cell, and this is interesting because we haven't talked about this before, we've talked about how in secondary cells, part of why they work is when the secondary cell is discharging. It's just doing its normal spontaneous chemical reaction or redox reaction. We have the products of discharge will move across to the electrodes, ready to have that reaction reversed in the non-spontaneous flip direction. But for a primary cell, the products of the discharge just move away from the electrodes. That's what they've got here. So it's not going to, like in a previous question, have the lithium ions go from graphite and then move across to the other electrode and move into that electrode ready to be reversed. For a primary cell, they actually move away from the electrodes. B, by referring to information provided in the data book, give one reason why lithium is used as a reactant in these galvanic cells. So, we've talked about this a little bit. We look on our electrochemical series, we look for solid lithium and we're like, that is completely down the bottom on the right for its half equation, which means it's the strongest reductant we see on the electrochemical series. So you can just say lithium is a strong reductant. You can say the lithium half equation has the lowest standard electrode potential, again just showing you know where that half equation falls. Lithium is more readily oxidized than other reductants. Lithium cells produce higher voltages because if you think about it they will, because it's so far down on the electrochemical series. And lithium has a low molar mass. And they just say lithium has a low molar mass, but I would say lithium has a low molar mass for the amount of energy it can produce. So it can hold a lot of energy, yet the battery can still be quite lightweight. So any of those will get you the mark. Question 7c. Some early lithium batteries exploded when exposed to water. Write a balanced equation including states for the reaction between lithium metal and water to explain why an explosion may occur. So, I will write this out. All you need to do is, we've kind of talked about this before, so we've gone through, this is not justifying it, this is writing the balanced redox equation, the full equation. Where's my text? Let's write this out. So, let's go through it fully, but you won't need to do that for the full marks. What you do need to do is explain why an explosion might occur. So that's going to be part of your marks. But we'll go through it fully. We will first find our two half equations. We have Li plus electron produces solid. So this is my first half equation. I know this is going to proceed this way because it's lowest down on the electrochemical series. Oh, not this way, sorry. I know this is going to proceed the opposite way because it's lowest down on the electrochemical series. So I'm actually going to write it out as lithium solid produces aqueous plus 1 electron. Okay, so that is my half equation for oxidation and for lithium. What have I got for water? I'm looking down. I know because my lithium equation was reversed. I just need to find water on my left-hand side. And about 3/4 down I do. I've got 2 O liquid plus 2 electrons. So 2 water plus 2 electrons produces hydrogen gas plus 2 hydroxyl ions. I'm very bad at typing and talking and thinking at the same time, I've discovered. So these are my 2 half equations. You don't have to write them, you just have to write the 1 full equation, but I wanted to write out what we've got. And then I'm looking at this, I'm like, well, I obviously need to add a 2 here, a 2 here, a 2 here, so we have the same amount of electrons. And then all I need to do is combine those. 2 lithium solid plus my 2H2O liquid, ignore my electrons, produces 2 lithium ions plus hydrogen gas plus 2 hydroxyl ions. So I'm looking over it. Does everything look balanced? Yep. I would also get full marks if I wrote lithium hydroxide. So I put my 2 lithium and my 2 hydroxyl ions together, but I don't need to do that at all. So either one works. It's all balanced, it all works good. So 2 marks are awarded for a correctly balanced equation. So usually, like most balanced equations, it's you get 1 mark for states and you get 1 mark for correct coefficients and products. So I get 2 marks for that. And then what else is it asking? Well, it's asking to explain why an explosion might occur. So we've already done a question like this. What are we producing when lithium metal and water reacts? Well, we're producing flammable hydrogen gas. And this is in a battery, so you've got electricity, so that could very easily be ignited, or just the hydrogen gas building up in pressure could also cause a battery to explode. So when we're talking about explosions in lithium metal batteries and stuff like that, we're always thinking about the products being produced, and hydrogen we know to be flammable, and also we don't want it building up in a battery due to pressure. So either of those work as an answer for the 3 marks. Do you have more? Okay, I'll go through D in a separate video because this is getting long.